Hey guys, so today I'd like to take our previous string obfuscation and look at a more advanced version of that. So this is obfuscator.io, and basically this tool transforms your original JavaScript source code into a new representation that's harder to understand, copy, reuse, and modify without authorization. So the obfuscated result will have the exact same functionality of the original code, but it'll be very hard to read. So on the site, let's take a look at a Hello World example. So we're going to use the default options, and we're going to go ahead and obfuscate this. And the interesting thing here is, outside of it being very difficult to read, is that there are a ton of options down here. And the thing to remember with these options are, if you go anything besides low or default and you start getting into medium and high, the code is going to run slower, and it even has a chance to impact the browser. I know when I was testing this, some of the medium presets with some of the other options selected actually hung Internet Explorer, and I had to restart it to get it to run again. So I would say generally, if you're an attacker and you're creating a phishing site, you want it to run more reliable and you want it to run quickly so that you can reach your target audience. Not that some probably aren't using the more advanced versions, but I would say it's a lot more rare. Okay, so let's take a look at an actual example. And you can see in this one, we have our stack strings here, just like we would expect. This is our string array, and this is being called out of this other function up at the top. So here's our function high, and yes, it says console log in here. This tool seems very hit and miss on the things it wants to obfuscate sometimes. I'm not sure if there's an issue with it right now or what, but generally most of the strings are going to be obfuscated in that stacked list. So let's see how this works. So it's going to call this function. This function is assigned to a variable, and it's going to call this main function up here. So if you follow this through, it's going to pass this OX7D into this function, and then eventually it's going to subtract OX78 from itself. So let's do that real quick. So you have 7D, you're going to subtract 78 from it, and you're going to end up with 5. Well, 0, 1, 2, 3, 4, 5. This is not the right value. It's eventually going to try to do the lookup here because it's reassigned a couple times, but it's eventually going to try to do the lookup here, and it's going to return that, and that is not the one that we want. So the thing that makes this tool different, outside of the other obfuscation that it's doing, is the root of this is that it takes the string array and it reorders it. And the way that it reverses that, or the way that it finds the correct order, is this anonymous function right here. So this is going to run at the very beginning, and since it's anonymous, it doesn't have to be called. It's going to run as soon as it starts. And what it's going to do is it's going to take in, so how anonymous function works is it takes in these values at the bottom here, right? So the first thing that's being passed in is this one, 27FB, and that is our function with the string array. And the second value being passed in is this hex value here, and that's being passed in right here. So let's take a look and see what this is. This is 467DE, and that is 288,734. So that's being passed in here, and we're going to enter an infinite while loop. This is basically the same thing as while true for JavaScript. And it's going to go ahead and it's going to do parse int here, and it's going to perform some math. And it's going to try to send this to the function. It's going to try to look up the values. It's going to perform the same math, and it's going to try to pull these values out of here. Now, the interesting thing about parse int, let's go to the page for that. So parse int basically converts the argument to a string and then parses that string and then returns an integer, or NaN, which means not a number. And the other interesting thing about it is when parse int starts going through a string, as soon as it hits something it can't convert to a number, it just drops the rest of it from that point on. So if we look at our example, the way they're doing this is you're going to end up with some numbers on the beginning of this string, and then they're just padded out with random characters. The only part that really matter for the math operations here are the numbers on the beginning, right? So we have parse int. It's going to grab the first part of these, and then it's going to perform some math. So let's say, for example, OX79. So you have 79, and you subtract 78, and you're left with 1. So if you take a look at 1, it's 6J, FE, whatever. Well, that's going to just return 6. And then it's going to do 6 divided by OX1 times this. It's just going to keep going down the list and down the list and down the list, and it's going to do all this math. So what is the thing that actually breaks out of this infinite loop? Is this part right here. So it's saying when the math of this that's set to this variable equals this value, and this value is being passed in right here, we already took a look at that, it's going to break. Else, if the math is successful, but it doesn't equal the right value, it's going to push and shift. So a push followed by a shift, which basically takes the string on the front and it moves it to the end of the array, and then the loop will continue to do that until it's in the right order. Same thing with the catch. Basically, if you end up with some sort of math that doesn't work out, it's going to, that's why it's in a try loop, right? So it's going to try to do the math, but if you end up with something that doesn't work with, for example, I've got this hello world here, it starts with an H. It can't do parse int on that. It's going to return not a number, and the math isn't going to work out, but it's going to catch that, and it's still going to do a push and a shift. So it doesn't really matter. So basically, it's going to reorder this string array until the math works out and it gets in the order that it wants. Now that we know some of these things that we need, there's some key values that we can use to create our own script to do this. We have to know this math so we can reorder the string array to the correct order. We have to know this value because that's the break value when it goes out of the while loop. We need to know this value up here because that's what it's being subtracted from each of these when it does the lookup. And we have to know other things like what function the string is in and things like that. So let's take a look at a program I wrote. It's frac, basically stands for fracture. And what we're going to do here is we can go over all the different parts, but I've got this set up so we can look at level 1, which I would be calling default or low on this page, or level 2, which we'll go over later. And there's also a third option, which will help you determine which one of these you need to run on it. Let's just look at level 1 right now. The other interesting thing of note here is when I originally came across this, I went and looked for a tool that could reverse this fairly easily. And it looks like there's many tools out there, but none of them work currently. And it seems like the Obfuscator IO, whoever's running that, is updating that fairly regularly. Now, I wrote this almost a year ago probably, and level 1 still works. They could change something tomorrow, and all of a sudden this doesn't work, but the basis for how they're doing this obfuscation will probably stay the same, and it's going to be something simple that breaks it most likely. Now, level 2 is a different story. Level 2 introduces a whole other set of obfuscation tactics, and so we'll look at that here in a little bit, but basically I did have to update level 2 when I was reviewing this, so it still does work with things that they're currently doing. All right, so what are we going to do with this, and how am I going to do it? Basically, I'm going to look at this with, we know what values we need, we know the basis for how this works, so why don't we use Python, we use some regex, we pull out the things we need, and then we actually add those to a template that I created, and then we run that template. It's a 2-stage process versus a 1-stage, but I think this makes sense because if something does change, it's a lot easier to go in and update a small piece of regex to fix the part that's wrong than to redo the whole entire thing. So let's go down through here and let's look at some of the things that we have. So we'll look at the if else print statements here because that kind of shows what's happening when we're doing the matching up here. But basically, we're going to look for the string position. We're going to look for the string array. we're going to look for the while loop, we're going to look for the string shift, and we're going to look for the while break value. I'll run this in a second and we'll compare everything. And then we're going to go ahead and we're going to grab all those values that we need, and then we're going to send them to our template. Let's take a look at our template. So this is the basis for a Python script, but we have some key values. You can see them here. And we're actually doing finds and replaces, regex replaces, on these from the other script. So the other script reads this one in, it finds these placeholders, and it puts the correct values that we need in here, and then we can just go ahead and run it. So we'll take a look at what that looks like as well once the template gets populated. All right, so let's run this and we'll compare the values and kind of see how it works. Here's your initial screen. We're going to do level 1 Deob. And the file to Deob is going to be level 1 example.js. All right, so I found all the important things that we need. So the first thing is the string position, and that's the subtraction value here. And you can see that OX78 is really decimal 120, so it found that. It found our string array. It found our while loop, our string shift function. So our string shift function here would be 578471, and you can see that's called with the parse int here. The actual one is reassigned to a variable, so we want the variable for that, and that's the part of the parse ints there. And the while break value loop is here, 467DE, and then it's saved out as level 1. So let's go take a look at level 1. So we have a parse int function here, and because we're converting from JavaScript to Python, it's not a one-for-one, so there has to be a special Python function to do that. So we're going to try to convert the first character to an integer. If we do not do that, it's going to return not a number. However, if the first one is an integer, we're going to go ahead and take all the integers until you get to an ASCII value, and we're going to go ahead and we're going to convert those into an integer, and then we're going to return that as an integer number. We have our shift, and basically what we're doing here is this is just mimicking the push and shift in JS with pops and appends. We have our main string shift, which is like we saw in the other one, where we're going to take our number and we're going to do string values, and we're going to do the number, and then we're going to take position shift, and that's going to be the subtraction value, right? And it's basically just doing our lookup for us. These are all of our key values, and our while true loop runs, and it goes ahead and does the exact same math for us. And then we go back through everything. We perform the lookups for each string. We replace those in the line. We convert some of the hex values that we need to convert. We get rid of unused functions that we can, and just general cleanup after we do the actual lookups. And then we write that out. So let's run that real fast and see what that looks like. So the aggressive pattern matching, you can pretty much ignore it for most cases. It's only there that if this fails for whatever reason, it'll go back through and it'll try to find the functions and it'll try to find the items again. So for now, just skip that, and you probably won't actually need it. It was a one-off edge case that needed it, but I've not seen one recently that actually requires that. So we'll say no, and let's see what it does. So it starts shifting the strings around in the while loop, and you can see that the string loop exited after shifting 7 times. So that means that it went through that while loop 7 times, moving that string list around. We go ahead and we parse the input file. We perform the string shift array lookups, just like we normally would now that the string list is right. And then we just do our general cleanup, and then we send it out. So let's see what our out file looks like. All right, so what do we actually have here? All right, so not all cleanup is done on this because there's still some of the key functions that we needed when we were converting this. So let's clean those up. So this is our string array, don't need it. This is our while loop. We don't need that. We're done there. And here is our position shift and string list lookup. We don't need that. Now all we're left with is our high function, with console log hello world, and then it calls hi. So we took that huge long thing and we reversed it back to more or less what we started with. Okay, so like I said, this is going to work for low and default examples, and we ended up with that nice clean function, and we started with this. So much easier to read. Now, level 2 is a little bit different, and let's go take a look at what level 2 might do. So if we take a look at level 2, which is medium in this case, it is disabling console output. It's self-defending, which means it's adding a lot of extra code to it to keep you from debugging this in a browser. It's adding dead code, which is just nonsense code that does nothing. The other items that are interesting here is it's using chained functions. And in this case, what chained functions is doing is it's using one function to look up the next function, to actually call the string list lookup. So you can't just grab the string list lookup, pass it to one quick function and subtract some values and reorder, and there you go. You actually need those along the way. So that adds complexity. The other way it's adding complexity is now, when I started doing this video, I found that it's actually doing encoding as well. Let me show you what I'm talking about on an example over here. So if you take a look at the string array here, we know that these need to start with numbers, right? Because it has to use parse int for the math and the while loop, which are still here. The while loop is still here. But the problem we have now is they all start with a regular letter or a character. So what it's actually doing is there's this new function that they just added here, all the way down to here. And it looks fairly complicated, and it's not as bad as it looks. And what's really happening here is the main part is right here. Out of this whole entire function, this for loop is actually what's doing all the work. So it's sending this in, it's performing some math, and then it's decoding all these along the way. The rest of this is either set up for the for loop, or for like this one, it's basically converting things. Here you can actually see it. There's a percent sign, and it's converting the output from the last for loop into a URI format, and then it's decoding that again. So it's reversing itself. There's not really anything to worry about there. The rest of it doesn't really do anything. The only part we really need is this. The other part is the chain functions that I mentioned. You can also see that there are 2 values now for parse int when it's doing these lookups, and you can see that it's calling this function. It's passing in 4 values here, and then it's only actually using, like for instance on this one, it's using the second value passed in minus a number, and then it's using the third value passed in, and then it's sending those to this function. And this is our decode function. Well, where's our string array actually called at? Well, we can see it's called in the while loop. We know that. The other thing to note while we're looking at this is instead of passing in one number, it's actually doing some math now to create that number for when it's actually going to break. So that's another little gotcha. So you can see this main decode function is decoding things as it needs here as well. So it's all very interconnected. So what we're going to do is let's take a look at level 2 and our level 2 template. So here's level 2. And we still look for the same things in this, really. The interesting thing, though, that we do need to do is we need the change functions. Like, we need those in the template. We need the decode script in the template. We'll go look at that in a second. So you can see we're doing some of the same things here. We got a string position, we got an array match, we got the while loop, and we're writing all those out to the same template sort of style. Let's take a look at that template. This template is a little more involved. So one of the things that I did on this one for ease of use is the way the conditional JS works in this for loop is, let me find one here. It's using the ternary operator for conditional operands, and it's doing an evaluation, and it uses the question mark. And then one item will be one result, and then depending on the condition, this will be the other result. So you can, if this was simpler, you can write this in Python, but trying to convert this in line is very difficult. So on this one, we're going to actually use JS to Py. We're going to put the decode function directly in here. And this seems to be the one they're using now. If it gets updated later, we could update it. We could try to find it as well. Like if it starts changing all the time, we could try to find it. I've been working on this on and off, updating this for about a week, and it stayed the same. So it would be very easy to update this. The other things that we need, we're going to put our chain functions at the top. We've still got our parse int shift main list here. We've still got our placeholders. It's very similar to the other one after we get through reversing a lot of the stuff. Let's go ahead and run this and see what this one looks like. We'll take a look at option 3 as well on this one. Level 2 example. So you can see that this is trying to identify the chain functions for us. Like if you weren't sure which one you had here, like you can kind of see that it's more complex, but if you aren't 100% sure, you could run it on there. And it's saying that this looks like a chain function. So you might want to run level 2. So let's run level 2 on this. All right, so what did we do here? So we have our string position, 401. Let's so find that. It's doing the math here. So if we copy that out, let's exit this real fast. Let's do the math. There you go. So it's actually got it expanded out, and we actually have to do the math on it this time, but there's your 401. Okay. Here's our string array. Here's our while loop. Here's our string decode. And here's our break value here, which again was a math statement. And so now it's saved that as level 2. Sweet. So let's go take a look at that. So what is it going to do? So it realizes that the values in the string array are encoded. So it first decodes those. Let's go take a look at our level 2 here. So here's our chain functions at the top, and these will vary depending on the complexity. But since this is very simple, we only got a few. But in longer scripts, I've seen it where this could be dozens. But we've got our chain functions here. We've got our decode function here. And then we've got all of our other values down here that we need. We've got our string array. We've got our while break, position shift. And that goes ahead and you can see here. So it decodes those. It finds the key values. It starts the while loop. In this one, it actually shifted and exited after doing it 10 times. Then it processes it, forms cleanup, and then sends it out just like the other one. All right, so things that we don't need here. We don't need this. We don't need any of this. Well, we could leave our high call. And then what we end up with is console log hello world, just like the other one. So again, we can do it. We go from something very complex over here to this. Remember, this is our initial one. Doing this by hand would be very, very hard, but using the Python script to do it makes it order of magnitude easier. Like I said, it's going to be an evolving thing. Level 1 will probably work for quite a while. Level 2 is probably going to need updated from time to time, but now that you actually see the basis for how these work and what all this is built on, any changes in the future should be fairly easy to fix. So that should about do it for today. In the description for this, I'm going to go ahead and link the code, and let me know what you think.